Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning programs. This is teacher Pascal, and today I will be with senior 4 chemistry students studying unit number 6. Today we are starting unit number 6. The trends in the chemical properties of group 1 elements and their compounds. And the lesson of today, lesson number 1, we will look at the occurrence of these elements. Where do we find them in nature? Their physical properties and how they react, the reactivity of these elements in the group. So we'll also have a look at the trend in the reactivity of these elements. As you know, we have been discussing the variation of physical properties in the periodic table, but we know that we have different groups of elements in the periodic table, and then what is next after finishing with the physical properties and the trends in the variation of those physical properties, what is next is to go in the details and look at how these elements react as well as their compounds, the physical properties and the chemical properties. So today we are starting with the occurrence, physical properties, and the reactivity of alkali metals. I hope you remember the name alkali metals. That is to mean elements of group number 1. So before we go deep in the lesson, let's have a look at the objectives, what you should know at the end of this lesson. So at the end of this lesson, you should be able to state where in nature we find some of these elements. Some of them are very reactive, some are radioactive. You cannot find them in nature, but of course we have some which can be found in nature. So you should be able to state where we can find them in nature. Objective number 2, you should be able to explain how various physical properties, you remember the physical properties we have been discussing, like the ionization energy, atomic radius, metallic character, electronegativity, and so on. So you should be able to explain how those various physical properties vary in that group as you move from the top to the bottom. And number 3, you should be able to explain how the reactivity of alkali metals vary. Here we have a table showing the elements and their physical properties. A summary of the physical properties, of course, but then here we have no explanations. So in the next slides, we will be explaining how each physical property varies, and we will use the data from this table, but actually we have data on each slide that we will use. So here it is like a summary of those properties. You can see we have lithium, sodium, potassium, rubidium, cesium, and francium. But in this lesson, we will not talk much about francium. Why? Because it is a radioactive element. So radioactive elements or radioactive isotopes, they are those elements which have nuclei which are not stable. So they constantly undergo a nuclear decay. Their nuclei keeps changing, and we cannot study those ones in the chemistry. We know this part of chemistry, so we deal with them in nuclear chemistry. So that is the reason why we will not talk much about this. And lithium, it has the atomic number 3, sodium 11, potassium 19, rubidium 37, and cesium 55. As we move down the group, the atomic number is increasing. You can see the melting point, which is decreasing from 181 up to 29. It is decreasing. So in the next slide, as I said, we will look at the reason why it is like this. We also have the boiling point in Celsius degrees, which varies in the same way. The density, you see how density changes. We have generally it is increasing from 0.97 to 0.86. Here there is an exception, but moving from potassium up to cesium, it is increasing. We will explain why it is like that. We have first ionization energy, which is decreasing, second ionization energy, which is also decreasing as we move down the group. Atomic radius, we have the electronegativity. Here is the electronic configuration. You remember the electronic configuration from unit number 3. And here we have the flame colors. These elements have a special property. And the special property they have, I'm talking about, is that they color flames. So if you burn them, you will produce characteristic colors. For example, we will use sodium to see the color of sodium when it is burnt. We know that it is yellow, but let me wait until we carry out the experiment to show you how the color looks like. So let's go to the next slide, and we start with the occurrence of these metals. Which substance do you remember that contains sodium? The substance which contains sodium that you remember, which is very common. The table salt, sodium chloride. Molecular formula of sodium chloride is this one, NaCl. So we have sodium in that compound. So as we know, do you remember where we find sodium chloride in nature? We know that seawater contains a lot of dissolved sodium chloride. So sodium and potassium are some of these elements. As it is said here, sodium and potassium are very abundant. And sodium is found as sodium chloride, as I was saying, in the seawater, and as sodium nitrate in the deserts of Chile. Potassium, too, is found in seawater, and also as carnallite. Carnallite is that, we can say, a compound salt which contains potassium chloride, magnesium chloride with 6 moles of water. So these are crystals of carnallite. Where do we find lithium? Lithium, rubidium, and cesium occur in a few rare aluminosilicates. Aluminosilicates are compounds containing aluminium, silicon, and oxygen. Those are the main elements we find in aluminosilicates. And as I said, francium is radioactive, and its longest-lived isotope, the one which can live longer than others, is francium-223 with a half-life of only 21 minutes. Do you know the meaning of half-life? Half-life means the time it takes for a given substance to reduce the quantity you start with to reduce to a half. So the time it takes for a given quantity of a substance to reduce to a half, it is what we call the half-life. So if you have, for example, 200 grams of francium-223, after 21 minutes, you will be remaining with 100 grams only. And after 21 minutes again, you will be remaining with 50 grams, and so on. So that is the meaning of half-life. So that is, in brief, the the occurrence of the alkali metals. Now, let us have a look at the physical properties. Here it will be just helping you to recall what we have discussed, because we covered all of these physical properties. So the alkali metals are placed in group 1 of the periodic table. They rarely form unipositive ions. Do you know why we classify them in the periodic table and put them in group number 1? Do you remember why they are in group number 1? What do we consider to put a given element in this or that group? The number of valence electrons. So because these elements have a single electron in their valence shell, their outermost shell, then we have to classify them in group number 1. But as you have seen, I didn't put hydrogen in that group. We are starting with lithium, we go on with sodium, potassium, but there is no hydrogen. And yet we know that hydrogen is in group number 1. Why is it like that? It is because even though hydrogen is in that group, it is only because of having a single electron in the outermost shell. But other properties, they are totally different from the properties we have of these other elements of the same group. So actually, we consider hydrogen to be forming its specific group. And that is the reason why we study hydrogen in another part, which is not the part of group 1 elements. So it is not a metal. You know that it is a gas. So we cannot classify it among the alkali metals. And here there is a name, alkali metals. Why are they called alkali metals? We will explain this when we will be studying the chemical properties of these elements. As we go down the group, the alkali metals show steady increase in size. You remember why? Why does the size increase as we go down the group? We have 2 factors which govern this. The screening effect, the nuclear charge, and when you combine them, you find that the effective nuclear charge becomes weaker and weaker as we move down because of the extra shell. And as a result, the size of the atom increases. Why? Because the nuclear attraction is becoming weaker. The electrons experience a weaker attraction and go farther from the nucleus, making the size larger and larger as we move down. So, as the size of the atom increases moving down the group, this will influence most of the physical properties of these elements, like the melting point, the ionization energy, electronegativity, metallic character, electron affinity. All those properties will be influenced by this change in atom and ion size. Some of the physical properties we are going to discuss are on the next slide, and these are the ionic radius, ionization energy, electronegativity, density, and melting point. So, the ionic radius, how does it change? On the previous slide, we said that the atomic size increases because we have an extra shell which is added. What about the ionic size? We have the ionic size, we have the values in picometers here, and for lithium we have 76. Sodium we have 102. So generally you can see that it is increasing, the size is increasing. So it changes in the same way as the atomic radius. As you move down the group, the size increases, be it for the ion or the atom. And here we have first ionization energy. What happens? For first ionization energy, you can see that it is decreasing. We have the values here. It's very clear. You can see that. Electronegativity, it is also decreasing. Density, as I said, generally it is increasing with some exceptions. And the melting point is decreasing. So let's go fast and explain why it is like that. Trend in the physical properties. We have the oxidation state here. All elements show a positive 1 oxidation state. And the atomic radius or ionic radius, we said that it increases down the group because we have more and more shells. Ionization energy decreases because as the size increases, the electrons experience a weaker attraction. It is the same for electronegativity. The tendency of these elements to attract the bonding pairs decrease as we move down the group because the size is increasing. So the nuclear attraction is becoming weaker. The ease of losing electrons will increase, of course. Why is it like that? It's because the size is increasing. So it is very easy to lose the electron. And here with the density, said that generally density increases from lithium to cesium as the atomic mass increases. As the atomic mass increases. So the size increases, yes, but the atomic mass increases also. So compared, we find the mass to increase more than the size, and this makes the density to increase. Melting point and boiling point, we know this because it has been the last topic to discuss in the previous unit, unit number 5. We have seen that as we move down the group, the size increases and the metallic bond becomes weaker. And as it becomes weaker, then what happens? It requires a small amount of energy to melt the substance or to boil it. Okay? Here we have the flame coloration. As I said, these elements, when excited, when their electrons are excited, the energy difference is too small so that the energy emitted when the electrons fall back to the normal energy levels, it corresponds to the wavelengths which belong to the visible part of the light spectrum. And because of that, we can observe different colors depending on the atom involved and the energy which is released. And then for lithium, we have crimson red. Unfortunately, we don't have lithium here, but we will be able to use sodium to show how its flame looks like. For potassium, it is pale violet. Rubidium, it is violet, and cesium, it is also violet. Now, without delaying, let me show you how the flame of sodium looks like. I put on our Bunsen burner and take a piece of sodium. Here we have a piece of sodium. I hope you can see it very well. And then I will try to melt it and burn it on a Bunsen burner flame. You may see some smoke because it is usually kept in oil to prevent its contact with air. You know, air contains water, and these elements are very reactive, as we will see in the next lessons when we will be studying the reactivity and the chemical reactions of these elements. And as we said, they have low melting points. You can see that it has already melted. So what is burning here, it's not sodium itself, it is the oil which we use to keep it. And we have to wait until it catches fire. And when it will catch fire, I will remove it from the Bunsen burner so that you can see what is happening. Look, that is sodium burning with a yellow flame. Sodium burning with a yellow flame, it looks like this. So, as I said, we don't have more metals of group 1, but for a simple comparison, we can use magnesium to show you how the different metals will have different colors if they can produce those colors. So here I have a magnesium ribbon that we are going to use just for comparison. You may think that all metals can burn to give a yellow color, but that is not the case. So that is the reason why I've decided to use this magnesium so that you can make a comparison. That is how magnesium burns. So you can see that it has a different color. So the different metals, especially these metals of group 1 and group 2, they have characteristic flames. And we go to the next slide. On the next slide, we have a video. You want to play and you watch how the different metals, these alkali metals, can react, or they react. So we are going to start to explain the reactivity of these metals, but before I explain, I want you to watch this video, and after I will give you the explanation. Here we have lithium. When you put lithium in water, you can see what happens. See, we have an observation that particle, you have seen it to be on the surface of water. And it means that it is less dense than water, as we have seen. And that is sodium burning. As it burns, it produces hydrogen which may catch fire and cause an explosion. So these elements are very reactive. But what I want you to see here is to identify how the reactivity varies as we move down the group. How does the reactivity varies as we move down the group? So if you put a very big piece of sodium in water, that is what will happen. And if we go to potassium, you will see what happens. Look, very fast. So the reaction is so fast. What do you realize? And here we have rubidium. Very explosive. So as we go down the group, the reaction is becoming more and more dangerous, more vigorous and more violent. You see, it can even break a bathtub very easily. Cesium, the beaker breaks. So you can see how it is very violent as we go down the group. So as we go down the group, the reaction becomes more and more violent. And there is a reason for this. As you move down the group, the reactivity of alkali metals increases due to the decrease in ionization energy. We know that. The atomic size increases, ionization energy decreases, and then metals become more reactive. And we have demonstrated that by using a reaction of them, or this video showing the reaction when they are reacting with water. Here I want to show you another example of how the the reactivity changes when we move down the group. We have some calcium and magnesium. What happens when you take a piece of magnesium, put it in water? You will tell me where we have a reaction, where it is reacting. Let us compare both. You can see that for magnesium, it's like there is no reaction. The reaction is very slow. But with calcium, you can see the air bubbles coming up. Showing what? Showing that moving from the top to the bottom, the reactivity increases. So calcium is more reactive than magnesium. Just like how sodium will be more reactive than lithium, and how potassium will be more reactive than either sodium or lithium. So reactivity increases as we move down the group, and for that reason. So I hope that you have understood what we have been discussing, and now it's time for the homework. Question number 1, explain how the atomic radius varies from sodium to cesium. How does the density of alkali metals vary? And you have to explain your reasoning. Whether it increases or decreases, you will suggest a reason for your answer. State the main source of sodium in nature. State the main source of sodium in nature. And next, which one between potassium and lithium is more reactive? Here you have to compare the reactivity of potassium and lithium. Which one is more reactive? And you explain your answer. Make sure you explain your answer. And the last, how does second ionization energy vary in the alkali metals? Second ionization, how does it vary in group 1 elements? Explain your answer. Thank you very much for your attention. Thank you very much for always being there to follow these TV learning programs. And I hope to see you next time for the next lesson. Stay safe.